Hello again. Today we're going to learn about Lab 6 and how to set it up. So first things first, you need 2 accelerometers, 2 wires with the connectors on them already, and 2 single wires with connectors on them. Your DAQ, your USB cable, and your screwdriver. So to hook up one accelerometer, you got, can you see? So the top one here, VIN, is the positive input power. You can input 2.5 volts to 16 volts. They have voltage regulators on them. The ground port is your ground in, your ground out. And then the Z, that's the axis we're worried about, because we're only worried about the Z direction motion of the spring mass system. We're not worried about X and Y. So those are the 3 ports that you need. Now VIN is what we're going to use to connect to the 5-volt in on our DAQ. So what you're going to do is you're going to take one of the wires of the connector and you're going to plug the red one into the 5-volt positive on the digital side. Use your screwdriver to tighten it. Then you're going to need to take your ground side, the white one, and you're going to put it in the ground next to the AI0 plus port. The reason why you want to put it here is on the accelerometer, the ground serves 2 purposes. It serves the purpose of completing the circuit to supply the power, and it also provides the reference to which it outputs the voltage for the Z direction. So you're going to put that in the ground port on your DAC next to AI0 plus. Then you're going to take one of the wires with the single connector on it, and you're going to plug the stripped end into AI0 plus and tighten the wire. This is the first semester, summer 2013, that you're going to be using the new setup for the accelerometers with the prongs, and you're just going to push them on, and that's how you connect it. So the black wire, which is the wire that's plugged into the AI0 plus port, goes into the Z port on the accelerometer. Then the other 2 wires, the red and white, the red go into V in and the white goes into ground, and that's shown right here like this. So you see the red wires in V in, the white wires in ground, and the black wires in Z. Now you need to set up 2 accelerometers for the second part of the lab. So what we're going to do is we're going to set up another set of connections. So we're going to put both red wires into the 5-volt plus. So you'll have 2 wires going into the 5-volt plus port on the DAC. So go ahead and do that. Then we're going to use the AI01 port, and you're going to plug in the ground cable, the red white cable, into the ground next to AI01, AI1. Then you're going to take your other black wire you have, and you're going to plug that into AI1 plus. And then you're going to hook up your other accelerometer like you did before. So in the first part of the lab, you only need 1 accelerometer, so you just define only 1 accelerometer. Then when you need to use 2 accelerometers, then you add in the extra channel. Keep in mind, these accelerometers have orientation. You need to make sure you get the correct orientation to get gravity. And the reason why we're using 2 is so you can see a 2 degree of freedom system oscillating at the same time. And you can collect data on both masses. And of course, you're going to hook your USB port into your DAC and then hook it into your computer so you can collect the data. And keep in mind, the weights that you're putting on with these springs, do not take the weights that are already on the springs off. Otherwise, you will get a 0 for this lab. So, this is how you do everything for this lab. And if you have any other questions, you can ask your TAs.
Okay, this week we're going to talk about Lab 6 and the VI you need for Lab 6. So this week you're using 2 accelerometers, and you're going to need to be able to convert the voltage output of them to acceleration. I'm not going to show you exactly how to implement that. You're going to have to figure that out on your own, but I will give you a guidance on how to do it. So first things first, you're going to put a DAC in as usual. Once you have your DAC in, then you put in a voltage as usual. And I'm going to select the first port as always, the I0 port. You can leave your full scale range as such, but I would change it to a smaller range, and you can figure out what that range is after you start doing your sampling. And the first thing you're going to need to do is change it to RSC since the accelerometers aren't hooked up in the differential method as usual. And again, remember that you can go to the connection diagram page to see what pins that you need to hook it to. Now for the second part of the lab, you're going to need to have two channels, so you can just come into your DAC again and add another channel, and you can say voltage, and then it would be your AI1 channel, and insert that, and then it would also be an RSC as well. You're going to leave it as N samples because you got to determine the proper sampling rate, and then once you have the DAQ set up, you hit OK. Has finished being put into the VI. The next thing you're going to do is, as usual, you're going to create controls. Now for this one, it's especially important that you create a control for this timeout, since you're going to be going for long periods of time, half a minute to a minute of data being collected. So you're going to want to make a control for the timeout, the number of samples, and the rate. Then the next thing you need to do is be able to convert the voltage output from your DAC to the acceleration. Now, you got to keep in mind that acceleration is in meters per second. Now, the accelerometer outputs in G's, so you got to multiply by gravity to get out of G's, and then you got to divide by the sensitivity of the accelerometer. So, say for example, our accelerometer had 150 millivolts per G sensitivity. So then what I'm going to do is I'm going to put in a multiplication and division block. So I'm going to put in, going to new arithmetic and comparison, then numeric. I'm going to put in a multiply block for addition. I want to put in division. Now again, you got to pay attention. Multiplication doesn't matter which one you choose, but on division, it's top divided by the bottom. So I'm going to take my data coming in, I'm going to multiply it by 9.81, and then I'm going to divide it by the sensitivity. So I'm going to create a constant because this value isn't going to change, and I said it was 150 millivolts per G, which is 0.15 volts. And then I'm also going to create a control here, a constant here, and I'm going to put 9.81 gravity. So now, if I graph this, then it will give me the output of the accelerometer in meters per second. Now, of course, it's going to be centered about 9.81 because that's the nominal output of the accelerometer when it's just at normal gravity range. So when you test your accelerometer, you got to note the direction because the direction matters on these accelerometers. You got to see what the output is on one side and see the output is on the other side, and you got to make sure it's 9.81, and then that's the side that you're supposed to have down, or depending on which side you choose. So make sure that your output is 9.81 before you attach it to the weights. So there's also one more thing you can do. You can also subtract out 9.81 and make the amplitude or the acceleration 0 for equaling 1g. But that doesn't really matter. And then as usual, you guys can save, create a measurements file and save it. You guys know how to do all that. So this is basically all you need to know for this lab. If you have any questions, you can ask your TA. Otherwise, that's it.